Very good evening friends, and in this video we are going to discuss about the rectangular Cartesian system, and this is a two-dimensional arrangement of finding out the position of a point. And this is a rectangular Cartesian grid system also it is called, because in two-dimensional geometry we have to represent a point on the two-dimensional plane just like this. This is my y-axis and this horizontal line is called as x-axis. So it's written like OX x dash, and this is OY y dash, and this is called the rectangular Cartesian system. In this condition, now if this is the understanding that if you go on the right side, so these points are positive, so OX is point positive and these are negative points. So this section is starting from the origin. If you go on the right side, this is positive. If you go on the left side, it is negative. Same way, standard says that if you go upward, this is positive. If you go downward, this is negative. So if you are here, like the point is here, then this point will be located how far it is from these two lines, OY and the OX. So first you have to draw, because we know that the minimum distance, like the shortest distance between the point and line, is always the perpendicular distance. So I have to draw a perpendicular from here to here. This is perpendicular and this distance is called as x. So the px is the perpendicular distance of point P from OY axis, and suppose this unit is x, and same way y is the perpendicular distance of the point from x axis, this is y. So this point will have the coordinate x comma y, and this first point x is called as abscissa, ABSCI, abscissa and ordinate. So this is x comma y. Now this is why this is called the rectangular Cartesian system, because you see always you get a rectangle or the square in this condition. Now if a point is here, then you get a line, but the position is always, so now this one here you find this coordinate is positive positive. So this is first quadrant. If a point is here in the second quadrant, then suppose it is P dash, then its coordinate will be minus xy. This will be its x and this will be its y. So this section, because we are on the left side, so this distance will be negative because you are moving on the left side of the origin, and this is still because you are upward, so this is positive. In the same way, if you have a point here, P double prime, then it may go like this, and here both x and y will be negative. And if a point is here, then you have the point like x will be positive and y will be negative. I can say q. Now suppose if there are 2 points and we are interested in finding the distance between them, or if you suppose there is another, this is point. Now I change my attribute and I make this point as x1 y1, and then there I have another point here, and that's coordinate is r x2 y2. So now again, because this is a rectangular system, so its abscissa will be this and its ordinate will be this. Now we are interested in this distance. So now see, if this line is line, so these two lines are parallel, so this is also going to be 90 degree. Now what is this coordinate? Because since I have named, I have changed this as x1 y1, so this will become x1, this will become y1, and this is my x2 y2. So this distance from here to here, this will be x2, and from here this will be y2. So if you just try to find out what is this distance, suppose I name it as m, then you see that this is your x1 and this is your y1 and this is your y2. So what is this point? This is y1 minus y2. Now same way, this distance is x2 and this distance is x1. So what is this? x2 minus x1. And now if this is a right angle triangle, so the Pythagoras theorem holds true, and the Pythagoras theorem says that PR square, so PR square is PM square plus MR square. PM square plus MR square. So the PR square is now this is, so what you get? This is x1 minus x2 whole square plus y1 minus y2 whole square. So at the place of PM I have written PM x1 y1. It's not that because this is this. PM is this and this is MR, but A plus B is always equal to B plus A. That's why this does not make any difference. And one more thing, this is x1 minus x2 whole square and y1 minus y2 whole square. They are also same, because x1 minus x2 whole square, if I take minus common, it will become x2 minus x1 whole square, and if you square this, it will become x2 minus x1 whole square. So a minus b whole square is always b minus a whole square. That's why even if you interchange the positions x1 y1 as x2 minus x1, and here y1 y2 as the y1 minus y2 or y2 minus y1, it will always remain same. And since we are not interested in finding PR square, we are only interested in finding PR. So I can say that PR is like this, and this is called the distance between 2 points. Now in the very next, just I have to clean the screens, just give me a break, and then I'll just wipe this out, and then I can come back to you and I'll explain you the idea of the. Okay, so now another point of location of a point on the two-dimensional grid is called as the polar coordinate. Now this is your point, this is, and this is a point. This is, you can call it as a pole. So a point P, suppose it has the coordinate x comma y. Now here we'll try to understand the whole thing in such a way that how far the object is, from the point, like this one. This is the point. Now how far this point is from the origin, this is your distance. And then we check another point with respect to the how much angle the point is making, the line joining the point with the origin. This line is making with this line, positive direction of y-axis. So here if I say that it will stay, suppose I start moving from here and then I go like this. So if I take 2-3 points, one here, one here, one here, okay, and then I put it here like this. Now see, so you can see that this point may have some other coordinate, and this angle, what angle? Now if the point goes, let's see, because angles are always measured in anti-clockwise, so I will have my line joining the origin and the point. It goes like this, and then from here I drop a perpendicular, and here it comes like this. So this angle, since angles are measured in anti-clockwise, I call it as theta. Now since you know that in terms of the rectangular Cartesian system, this x, like this distance is your x, this is perpendicular distance from here to the y-axis, so this will be x, because this will make a rectangle like that, and this is opposite sides of a rectangles are same, so this is x, this is also x, and same way this is y. So now use trigonometry here, because you see that what is y? Y is just opposite, so I've used trigonometrical ratios called as sine theta. This is called as sine of this angle theta is opposite upon hypotenuse. Now what is hypotenuse? That is r. I call it as r. So So this you can say y upon r. And now what is cosine? That is cos of theta is adjacent upon hypotenuse, that is x upon r. So you get y equals r sine theta and x equals r cos theta. Okay, so you see x is the abscissa and the y is the ordinate. R is the distance of the point from center to the point itself, and the theta is the angle made by the line joining the origin to the point with the positive direction of x-axis, and this is that angle. So here this is r cos theta. So if I say that this coordinate can also be written as r cos theta and r sine theta. This is called the polar representation of a form. And now if you want to establish the relation, then you see that the sine theta will be y over r, cos theta will be x over r, and you know that the square of this, like sine square theta plus cos square theta is 1. So sine square theta plus cos square theta is 1, means y square over r square plus x square over r square is 1, and this gives you x square plus y square equal to r square. This is again, what does it represent? It represents the equation of a circle with the center 0, 0 and the radius r. Means if you keep on rotating this point like this, then you will have circle, and in this case angle will be changing. The theta will be anything more than 0, less than 2 pi, that's 180 times 2, that's 360 degrees, and this is the r. So this is the idea of the polar coordinate system. I hope you got the idea clear. Thank you very much. Just keep on watching our videos.